Hey guys, Mr. B here, making you another lovely math video. This one on finding the vertex of a quadratic and what I like to call the easy way of doing it. So some of you guys probably have seen my other video and probably learned in class. One of the more common ways of finding the vertex of a quadratic is through completing the square. But that's actually, kind of a pain to do, and it's the hard way, I think, to find the vertex of a quadratic. The way that I like to show my students, and the way that I support them and help them and encourage them to use during exams and tests and things like that, is to use the axis of symmetry. So if you're not familiar with this formula, the axis of symmetry is equal to x is equal to negative b over 2a. And in reality, this actually comes from completing the square on y is equal to ax squared plus bx plus c. So if you completed the square and changed that form, that's what you get as your x component. In your, I guess you'd call it your, depending on what you've taught, transformational form, standard form. What I tell my students is vertex form. So this formula actually makes it a lot easier to find the vertex. So what we do is we use this formula with our b here and our a, and this gives us the x coordinate of the vertex. So you know this formula, it's called the axis of symmetry. It helps us find the x coordinate of the vertex, the horizontal translation, whatever you want to think of it as. So let's see it in action. So we got a quadratic function here. We're asked to find the vertex. So x is equal to negative b over 2a. So negative b is negative 4, so negative 4 divided by 2 times 2. So that's 4 on the bottom. So I get negative 4 is positive 4 over 4 is equal to 1. So the x coordinate of my vertex is 1. Now to find the y coordinate, all I need to do is sub that 1 back into the function to find y. So y is equal to 2 times 1 squared minus 4 times 1 plus 3. So that's going to be 2 subtract 4, which is negative 2, plus 3 is 1. So my vertex of this quadratic is, it's a little messy. My vertex of this quadratic is 1, 1. Pretty straightforward. Let's see another example. So again, I got a quadratic function, just like that. So I have x is equal to negative b over 2a, negative b, so I have negative 4 again. So negative 4 all over 2 times, in this case my a value is 1/2. So it looks like I'm going to have positive 4 on top, just 1 on the bottom, 2 times a half is 1, or just 4. Now I need to sub it back in. Y is equal to 1/2. 4 squared minus 4 times 4 plus 6. So 4 squared is 16 divided by 2 is 8 minus 16 plus 6. So that's going to be negative 2. So in this case, my vertex is 4, negative 2. This way is also great if you want to change something. If you're on a test and your question is change this to vertex form, well, all you need for vertex form is your vertex and the vertical stretch, or your a value. So in vertex form, it would look like this. Y is equal to 1/2 x minus, background sneezes, minus 4. So there's your x coordinate on the vertex squared, and then minus 2. So that would be your vertex form. So it also eliminates the need of completing the square when you're just trying to change form. So that's another really interesting application of the axis of symmetry. So hope this helps, guys. Got any questions, feel free to ask. I'll see you in class.